Today what we're looking at is finding the volume of a pyramid or a cone. And with the volume of a pyramid or a cone, again, there's not going to be a whole lot of difference from what we did yesterday, except the volume, instead of using the slant height, uses the actual height. So now the actual height of our pyramid is what we're interested in, this segment right here. So surface area uses slant height. Volume uses the actual height. They're both part of that same right triangle that we learned how to solve yesterday. And the third side of that is still the apothem of the base, which again is very often, if you have a square-based pyramid, half the side, pretty easy to find. So now we actually need to use two different heights of the pyramid. It's going to add an extra measurement for us, but it's something we do. Volume is very simply the base area times the height divided by 3. Now you're probably wondering why divided by 3 instead of divided by 2 since it's triangular. In class we can actually do a little experiment where we can pour water into similar sized prisms and pyramids because we know that base area times height is the volume of a prism. And if we have a similar pyramid, I can actually fill it with water 3 times and it will fill up the prism. So it is 1/3 of the volume of the corresponding prism. The prism would be triple the volume. So that's why we have base area times height divided by 3. So one new formula here, that's really the only new formula that we're going to be dealing with. Other than that, things work pretty much the same as what we did yesterday with surface area. It's just that now we have to know both the height and the slant height. So let's take a look at something. Let's take an example. Here I have a square-based pyramid. We're going to go ahead and draw in the necessary parts. I'll say that the one side of this square is 14 centimeters. And I'll give you the height here is 24 centimeters. Let's find everything we need to know about this pyramid, surface area and volume. So just like before, we start by finding the perimeter of the base. We're going to need that. Well, it's a square. 14 times 4, that's pretty easy, 56 centimeters. Now, we need to know both the height and the slant height in this case. The height is very easy because it's given to us. It's 24 centimeters. The slant height we're going to have to calculate. Now, I've got this side of my right triangle is 24, but I need to know this side. But since it's a square base, that's pretty easy. That's going to be 7 centimeters. So I've got my Pythagorean theorem to do. 7 squared plus 24 squared equals c squared. So that's 49 plus 576 is c squared, so 625 is c squared. And it is set up so that c is perfectly 25. Next, let's start finding our areas. My base area. Well, base area, that's a square. It's going to be easy. 14 squared. 14 squared is 196. My lateral area, to remind you of yesterday's formula, is perimeter times slant height divided by 2. So I take 56 times 25, which is 1,400, and divide that by 2, which is going to be 700.
I remember this stuff.
The total area is the lateral area plus 1 base, so that's going to be 896 centimeters squared. And now the new thing is the volume. And again, all of these figures down here are these are all figured based on the numbers up above. The volume is base area times height, not slant height, h height, divided by 3. So my base area was 196. My height was 24. And we divide by 3 is 1,568 centimeters cubed for this volume. So that's pretty much our procedure. Very similar to what we did with prisms, very similar to what we did with surface area. The only difference today, what we've added in is we've added in finding the height and using that to find the volume. Other than that, it's the same thing we were doing yesterday. And this is just kind of a written summary of that in case you want the notes. Remember, the height is on the inside of the polyhedron. The slant height is on the surface of the polyhedron. Cones, again, working the same way as pyramids. Again, we tend to work in exact values with these things. Here, I'm given the height is 12 inches. The slant height we're also given is 13 inches. What I don't know is the radius of the base. So r squared plus 12 squared equals 13 squared. We have to set up our Pythagorean theorem that way. It's a little twist on the whole thing, but not so bad. So r squared is going to be 25. So r is very clearly 5 inches. From that, we can calculate both the perimeter of our base, which would be pi times diameter, 10 pi inches, and the base area, which is pi r squared, 25 pi inches squared. Now we're right back to our normal formulas. Lateral area, perimeter times slant height divided by 2. Perimeter of the base is 10 pi, slant height is 13. That'd be 130 pi, but we have to divide by 2, so 65 pi. The total area is simply the base area plus the lateral area, so that's 90 pi. Oops, we need a pi there, not 900 pi. 90 would be better. My volume, that's the new one. Again, base area times height divided by 3. Most people forget the divided by 3. They just do base area times height like they do with prisms. So 25 pi times 12 divided by 3 is going to be 75 pi inches cubed. Now, some people get upset. They're saying, wait a minute, the volume is less than the total surface area. Yeah, but they're different units. There's really no rule that one has to be larger than the other. The volume was a bigger number on our first one than the total surface area. But again, different units. Sometimes one's bigger than the other. That's the way it is. This would be like a more complicated thing. We're looking for the total area and the total volume. Notice I haven't listed everything here. We would have to do a lot more calculations. But we can go ahead and work on this. In fact, what I want you to do is actually pause the podcast at this point and work this problem out to the best of your ability. That will be what I'll be checking to see if you've actually watched the podcast today, is see what you have for this. At the very least, you ought to be able to find the volume of that cube on the bottom. It is a perfect cube. Every side is 8 centimeters. And that also makes the top, by the way, the height here, notice everything's congruent, that this is also 8 centimeters. That's going to help you an awful lot setting things up. Your slant height is going to be a little bit tricky. That's going to give you a radical value. So I want you to work on this, pause the podcast, and actually end the podcast here. That is your assignment to work on with this podcast.